Okay, let's get started. First thing first, TA already gave you the answer of your exam, right? So I would like you guys to redo it again. This time you have the spreadsheet, you know the answer, and give you more time. But the bottom line is try to develop the spreadsheet, the answer from scratch. I think part of the problem is, 2 years ago, when I give the exam of this class or homework of this class, I don't give the Excel file. I just give the PDF and ask everybody, develop the the Excel step by step. Okay, and this time, okay, I feel like, okay, we'll do it your way. Well, I'll give you the Excel file, and the assumption is you use that to develop your own, but you think through step by step, not plug and play. But at the end, I think some of you still plug and play, and the thing is that, everybody thinks that, 16 number or 25 number, how hard could it be? How many different things you can, get trapped? There are many different ways you can get trapped unless you think it through logically. So I still feel like, there are two sides of this, okay? I can just pretend there's nothing and then just curve and then let you pass without caring if you really know how to do it. But you're gonna curse me 5 years from now when you actually work in the field and somebody asks you to design an experiment and then you just couldn't plug and play your Excel spreadsheet. Okay, please think it through logically. This is not a, put your suit and ties on and then let's talk big type of techniques. This is experimental design, by definition, is how to design experiment. And you're gonna get a bachelor degree, BS or MS, right? And it's bachelor of what? Science, right? So what is science? Something you can repeat, improve, and defend your decisions based on those numbers, right? So try to get that right this time. Try not to copy paste, because you copy paste, you get a false sense of security. It's gonna be bad. Originally, I planned to talk about SAS today. I plan not to, because I feel like if I give you SAS, you will see that just click, 2-3 lines. Everything will be done in the background. And then you will feel, so I get the numbers. The thing is that, guess what happened when you use something powerful like SAS? Later you can get caught. And in system engineering, not always the case, but a lot of you could end up 2-3 years from now and say, I would like to get my PE license. You guys know what is PE license, right? And when you try to get your PE license, that means what? You're gonna sign something later to prove that. And then guess what? That signature gonna end up on the good side is a very good salary. On the bad side, you could end up in a court. And people said that, how did you cook your number? Right? You cannot say that, I got an Excel file, I plug it in and I got a number. You need to say that, I think it through. Here is the logic and here's is something you can defend. What I'm saying is that Do you think we can talk about this without right or wrong? We can, right? If you got a number, you got a number. You don't have the number, you don't have the number. You cannot lie about it. You cannot just say that, I prepare for it. That's nonsense, okay? So, I still would like you to try. And the other thing is that originally I planned exam 2 will be more SAS oriented, but now I think we probably still want to do some Excel. Until, TA and I kind of agree that sufficient number of you actually can get the number from scratch. If I see that, you actually understand what is that central station, what is that regression line, what's response surface, and everybody actually can visualize it, then we're using SAS. And SAS is really quick, but there's, Triangle Park, now there are 2 different type of company. Actually, Charlotte got similar type of deals. One is what? Bioinformatic or, data mining, cloud computing type of company, right? They hire people everywhere. And the other one is those pharmaceutical company, because we know the reason. And the thing is that, so I think the job market is good. That's good news for us. But I think it's important that you can do it from scratch. Okay? Do you guys agree with me? If we plug in and then it's almost like you have a spreadsheet, right? You dump in 16 number, random number or whatever, you'll get a ANOVA table out, right? Agree? But if you just dump it in and get another table, ANOVA table, does that mean you really know what's ANOVA? What is regression? And well, I want to just say that please go through that step by step and try to answer the questions. You can look at it, but when you're done reviewing it, you should have the confidence and say that, okay, I'm going to throw everything away. Start from scratch and step by step until you reach the p-value equal to some value. Okay? So in other words, is that nothing you can use. Okay? I even consider that some of the textbooks, they have the F-test, F distribution, T distribution, normal distribution in the back of the books. That's bad too. Because what you're really doing is that, okay, I check the books. The books in the back said 90 miles per hour, you're 95, I should give you a citation. But where are that 90 miles coming from? You don't really know, right? And that is kind of like, you find a surrogate to pretend you know the whole things, okay? I really think that you should start from scratch, nothing in front of you, okay? I don't have my PhD students anymore. And guess what happened when I have grad PhD student with me? They love to do this. They love to use PowerPoint presentation. I'm doing PowerPoint sometimes, right? And what's wrong with the PowerPoint presentation? Look nice font, nice figure, not nice everything, and you just go through those things, read it, and with some animation, you feel like you know something. What's the kind? Well, even when I work for Liberty Mutual, we interview people, right? I usually will say that I don't want to see your PowerPoint. Okay, I want you to start from scratch. Here's a whiteboard. You go through your code or your procedure line by line, how you're going to get to the bottom line. Okay? Because when you do it that way, you know you really know something. But if you rely on some cheat sheet or some PowerPoint, you fake, I fake, and then we all fake together, and that's wrong. Okay. Let's go through some of the stuff again. Okay. Here are some readings, and what I prefer you to do is not go through a reading first. Go through the 3 example first. I give you the Excel, right? The 3 example, basically, they're doing exactly the same computation procedures, okay? And if you go through the Excel, okay. The only thing difference is that, okay, you have the 2x2 was the 4 number and 4 numbers. And then if you go through the Excel, there are 3 blocks, got 4 numbers. So in this case, okay, chapter 7 and chapter 8, the major difference is there's no confounding. In other words, block is block. And so you see here are block 1, here are block 2, here are block 3. So when you do the x transpose x, and at the end, you can dissect and get your sum of square out. Okay? And then for 7.2, the example, okay, you have 2 blocks, finish half of them, finish off half of them, so totally 16 trial, separated into 2 blocks. But this time, since block 1 got half of it, but block 2 got half of it. So the contrast, the differences between block 1 and block 2, okay, is the same things as the ABCD, because we use ABCD to separate the 2 blocks, okay? And the things I ask you to do is this, okay? How many of you know that the block code and the ABCD code are the same things? How many of you can prove that? I have 2 here. Look at the graph on 7.2. 7.2 is 2 to the 4, right? So how many numbers if I have single observation? 2 to the 4, 16, right? And 16 I separate it into 2 blocks, okay? And if I separate it into 2 blocks, okay? People, can I use A as the separation and say A positive in 1 block, A negative in 1 block? Can I do that? Can I? Well, if I do that, I'm confounded something very important, right? Can I use B as the separations? Sure, I can use any one of them. I can use ABC, ABD, anything you want. But the one we did is using ABCD. And I already did it before. I can show you again. A, B, C, D. If you use the product of the A, B, C, D. Oh, wait, I don't have it here. Let me see. Yeah, okay. If I use the product of A, B, C, D, okay. Huh? Oh. You'll see that the block in ABCD exactly the same sign. In other words, whatever I can use the contrast, the effect I can use to talk about the block and to talk about the ABCD are the same things. So in exam 2 or in the future, what really important is this, okay? Computationally, there's no difference between what we did right now and what we did before exam 1, right? It's just x transpose x, and then find the sum of square and everything. But what is the major differences between exam 1 and exam 2? Young man, are you sleepy in the back? No, further back. No? Okay, so can you tell me what's the difference? You know, we're doing the same x transpose x, inverse x transpose y computation, right? We're not doing anything different from the exam 1. So everything we're computationally, Excel is Excel. What's the difference between exam 1 and exam 2? What's the difference between exam 1 and exam 2?
Will we be doing that in SAS?
Huh?
Everything will be done in SAS?
No, originally that was the plan for exam 2. Everything will be in SAS. But now I said I still want to use Excel for a while because I don't feel confident. Because the minute I let you use use SAS, it's easier for me to make up exam, easy for the TA to grade. The problem is, you know the expression, the emperor has no clothes. So in other words, is that we're just afraid to point at the emperor and say, hey, the emperor is naked. Okay, so that's not the point. The point is, what I'm trying to say is, exam 1 and exam 2 basically said, hey, I can use the block as my stepping stone to make my computation easier. So in other words, is that here, the minute I say A, B, C, D, and this is the same, do you think we really want to run 16 trials? This it's easy for me to random number everything, right? In the classroom, it's a few seconds. But in real life, you need to collect data. You need to clean, you need to wash the tubes and do a lot of labor intensive and cost a lot of money, right? How many of you think that, we did all kinds of testing right now using 3D printing to do a lot of parts design. It's very popular right now. Okay, they even said that in the future we probably will have a 3D printer in Mars or on Mars or have a lunar base, and they just use whatever the material they can get from Mars or on the moon, and then print the parts. Okay, and when you do that, how do you know your parts are reliable? You need to run some experiment on Earth to make sure that happens, right? And for that kind of stuff, 3D print everything. It's cheap. But it's really cheap. Relatively cheap than before. It still costs tons of money. So you need to prove that it's doable. So what I'm trying to say is that exam 1 and exam 2, the major difference is what? Come on, people. What's the difference? You're a system engineer. If people ask you that questions, why you use block? We talk about this in exam before the beginning of the semester. What is the reason we run blocking design?
It's time and money.
We want to save time, we want to save money. Sooner or later, I don't want to do, here. I know I can do 3 blocks. Okay? I know that I can separate things into 2 blocks. But the reality is what? I know how to do this in order to do it only half, only a fraction of it. Okay, that's why it's called fractional factorial design. Right? So in other words, is that if you coming in and tell me that, oh, I'm going to full factorial everything, why should I hire you? I want to hire someone who can just use half of the money, half of the budget, and tell me the same thing. Okay? So the exam 1 and exam 2, the major difference is you need to prove to me that you can run experiment, okay, or design experiment only using still x transpose x, x transpose y, but you only use a fraction of it. And if you do that, okay, then later on, we can say what? Well, if I can, here, the stuff actually I plan to do is this, on 7.1, 7.2, or 7.3, okay? People, if I said I'm only using 2 blocks out of 3 from 7.1, do you think you will get the same? Here, look at table 1, table 7.2. A is significant, right? B is significant, AB is not significant, right? Right? And if I said that, can you prove that only using any 2 blocks rather than 3? Do you think you can do that? It's doable. Same computation and everything. And if you can do that, that means what? Your colleagues will get Christmas bonus if he only used 2 out of 3 blocks and you using 3 blocks. Why? The boss will say that, hey, each block cost me 10 grand. 3 blocks is 30 grand. But your colleagues can do using 2 grand to get that, so I give him 5 grand as Christmas bonus. To the boss, that's still a good deal, right? Yeah, that's the part that I would like you to do. So 7.2 is the same things. Okay, there are block 1 and block 2. Here is the ANOVA table you're gonna build. Okay, if I'm only using a fraction of it, only half of them. So in other words, is that if I run the experiment and then say that, okay, I'm gonna do x transpose y only using the upper A observation or the bottom A observation. So in other words, now I'm using a fraction of it. I'm still getting the same answer, the same significance. Okay, then I don't want to do 2 blocks. In 7.3, the same things. This time is, I have 8 trials. Okay, confounded by different things in order to have the effects out. And then what it's really saying is that for all the effects I try to investigate, if I can get the same number on the significance part. Okay, so what is important, what is not important, still the same. Then do I need to run the whole things? Okay, That is the motivation behind exam 1 and exam 2. And so, yeah, I can tell you that what will happen in exam 2 will be, I give you something. And I said that, okay, how many different ways I can, here, you guys know the expression, a bunch of blinds try to figure out the elephant, right? The blinds and there's an elephant. Nobody heard that expression before? Okay, let me see if I can Google it. Okay. Blind. An elephant. Yeah. Okay. Oh, the image is bad. Let me try a different image. Okay. So, whoop, that's bad too. I'm trying to, okay, maybe this one. Okay. So, there are 5 people blind trying to figure out what is an elephant, because the blind never seen an elephant. Okay, you touch the trunk, you think the elephant as what? One big hose, right? You touch the ear, you see one thing. You touch the tail, you see something different. So, what will be the argument you have here? You need a 4 factorial design to figure out the shape of the elephant. But in reality, sometimes I can use only half of the deal to figure out the thing I need to figure out. Okay? So, for the another set of homework, after you guys finish the exam, I'll do the same things for 7.1, 7.2, 7.3. And I'll get a few. Here, let me find the A1, A2, A3. Do I have chapter A? Okay, here we go. So here is the part that I'm going to ask you to do. Is this. For every trial, okay, you can use the upper half, you can use the lower half, A1, A2, okay? Or, basically discount one fraction of the x transpose x and then do the computation. I give you the sum of square. And your job is to figure out that, is there any difference? And why you need to figure out, is there any difference? Because if there's no difference, means that from now on, you can use a fraction of it. But if there's a big difference, then you have to use the 4 factorial design, okay? How many of you download SAS already? Everybody download SAS or not yet? Okay, so I just stopped. Oh, I still can. Huh? Okay, I need to ask the school, the Mosaic to have the SAS available.
So actually there is this online university edition available. There's no need to download.
Huh?
University edition is available.
So there is a university, well, for us, university edition is, you don't need industrial editions. University edition is good enough to run through most of the works we need to do, okay? Only you're dealing with cloud computing or data mining, you need the larger version. Now, I asked Mosaic to download one for me here. Obviously, it's still not working. Okay, And what I plan to do is once SAS is loaded, for every homework we did in Excel, we'll repeat one more time. But this time just using the SAS code. And to show you that how you can get the answer, okay? And that one takes too long. Okay. Let me get through this. Okay, now I want to show you in expressions that this can be used in the computation of which part to save. Okay, this is done in the old days when Excel is not available. People are using Fortran to do it. So if you're using Python and writing Python code, and this is the similar way to do it. It's the following, okay? I already showed you, right? You can sort all the positive on one side, all the negative on one side, or, you know, 2 columns, both positive, both negative, one positive, one negative, to separate them into 4 blocks. Can I separate them into 8 blocks? Using 3 confounding factor, just 2 by 2 by 2, and to do that, and just sort, okay? But in the conventional way, you're writing it like this, okay? You write it as a linear constraint. A, x1, x2, x3. So watch here. If I have A, B, C, 3 factor, will be right as L as x1, x2, x3. Okay? And then when I put it down, I can just have the 0, 0, 0, 1, 0, 2 computation. So every time positive and negative, you just put 0 and 1. That is the code you put it in like before. So when you put a code in, the sum product will equal to what? Either 1 or 0, right? So when you end up with 1 or 0, you basically said, hey, 1 on one side, 0 on the other side. Then you can separate this whole thing into 2 blocks. Okay? And the other thing is this. Okay? We basically said that when you have 2 things, you confound it, okay? And you can tell AB, AC become A squared BC. And remember, this is based on the -1, +1 expressions. A square, -1 square, and +1 square, the same. So no matter -1 or +1, doesn't matter. So you can separate the whole things by using this 0-1-0-1 combination with the mod to block them into 2 blocks. Okay. And here is the 4 and to the K components, okay? And when you have 2 blocks, and I mean, first time you block one thing, and second time you block another things, okay? So in other words, the replica of 1 using ABC as the confounding, and then second replica use AB as the confounding, third block use BC and AC. So in other words, every replica you're using different thing to separate them. This is called partial confounding, because here I confounding one things, here I confounding another things, here I confounding another thing, here I confounding another things. If 4 replica with 4 different confounding, what's the benefit? What's the benefit of every replica using different confounding factor?
So if it turns out that the ABC effect is significant, then when you replicate it again with the AB effect, then you can test and see how it changes from one confounding to the other.
So in other words, is that there are a bunch of blind trying to figure out the elephant. Nobody got a full picture. But now at least we have enough of them testing the trunk. Some testing the ears, some testing the legs. So in other words, is that nobody have the whole picture. But the overlapping still give you some idea of the elephant. Agree? The only things important here is, can anybody tell me, will we use, when we do the major confounding, we don't want to use main effect or two-way interaction, right? We want to keep the resolution high. When we do partial confounding, will we surrender and say, let me do A, confound B, main effect? In partial confounding? We could, but usually we still try to stay out of it. So generally speaking, I don't care. You're doing partial confounding or you're doing, whole so in other words, I can have this replica here. Young man, I asked you a question, you didn't answer me. So let me try this one for you again. You can you hear me? Okay. Can I have replica 1, replica 2, replica 3, replica 4? All 4 doing ABC confounding, ABC confounding, ABC confounding. Can I do that? Why not? I want to be different, but can I say that I don't want to be different, I just want to ABC all the way? Can I do that? Can I do that? Okay, let me ask you the question this way. Let me give you the answer. I can do that. I can just ABC confounding, ABC confounding, ABC confounding, ABC confounding. Boom, boom, boom. All shots. Just confound ABC. Okay? But obviously I did not do that. Okay? What's the difference between the two? This is the type of questions I would like to ask in exam 2. Because in exam 1, you already have the mechanics done, if you train good enough. Do you think that's an intelligent question to ask? Or your boss should ask? Why we want to do partial confounding? Why cannot confound all the way? Say that. Why? If I confound ABC all the way, what does that mean?
Everybody's only looking at the trunk.
Or basically said that, you know what, elephant tail is something we don't care at all. Even you tell me elephant tail is very, very significant, important, I don't care about elephant tail, which is ABC confounding. And if that's the case, I'll just say that give up ABC. So in other words, fractional confounding versus full confounding. Which one usually got more confidence? If you're doing full confounding, means what? I know for sure something I don't care, and I don't care. Okay? But if you kind of like, I don't have the guts to say that, then I'll say that, okay, let me give you a little bit chance to investigate that. That's the difference between partial confound and full confound. You guys see the difference? Huh? Yeah, this is the the things, yeah, the smart, the intelligence you would like to have, okay? Okay, and let me spend a little time on what we're gonna do for after you guys finish the redo the exam. I give you the second part of the homework, cover what I just did. After that, we're gonna get into the three-way factorial design. Okay, and what is the difference between two-way and three-way factorial design? Anybody? Of course, for an intro class, we're stopped at a three-way. I can go four-way, five-way, but it doesn't matter. Usually, we can go with three-way factorial design. What's the difference between two-way factorial design and three-way factorial design? Here, in two-way factorial design, either A is low or A is high. B is low or B is high, right? Right? Three-way factorial design means what? We'll have three levels, okay? So, basically, you can have a low, medium, high. Low, medium, high. And if you have low, medium, high, what are you really looking for? So, if I show you the Excel and you guys just copy paste, it's 5 minutes done. Okay, but I don't want to do that. I want you to think about it. Why I want to have three level? Anybody? Last time you answered blocking really well. Want to give a shot? Oh, okay. Young man, your turn.
What's the question again?
We just gonna finish the two-way factorial design, right?
Yeah.
But now we're saying that, okay, I want to do, three-way factorial. Three level, low, medium, high. When I do low, medium, high, rather than just low A, high A, what does the low, medium, high three level gonna give me?
More intersections between the points.
Okay, and there's something else. Okay, here your oven. Okay, if it's linear. Low, not cook. High, cook. The world is between low and high, linear. Okay? But the minute I say that, we need to have this low, medium, high, we need to investigate somewhere in between. Okay? What does that really mean for a system engineer? It means that there is a middle point somewhere there can give me something better performance or lower performance. In other words, is that if I don't believe the world is linear, I believe that it's nonlinear. In other words, is that if you go low, my performance is not good. You go high, my performance is not good. But somewhere in between, medium, my performance actually a lot better. If I'm looking for maximum, that will give me higher value. So I could end up low, high, low. if you have that gut feeling, then you can convince your boss to spend more money. If you don't believe there's somewhere in between going to make things get bigger, or of course this can be the other way around, right? High, low, high, if I'm looking for a minimum. So the minute you have 3 level, okay, you don't propose a 3-level experiment just to show that you can do ANOVA in 3 level. You only propose that when you think that there is something deserve the investigation.
So you're pretty much doing it when you think that the 2 points are not linear?
That's the very concise way to say what I said in in the last 2 minutes, 3 minutes. Exactly. Yeah. If you think that, okay, here. If you think that the world is linear, okay, then you know that you can linear interpolate it, right? So if here, I know how to show that mathematically. Okay, this is A, this is performance. Okay, and then when A is 30, the performance is 250. And when A is 60, the performance is 500. Okay? So if I ask you, what will be the performance when A is 45? Somewhere in between, right? Under what situation you said that I don't need to run another experiment?
When it's exactly the middle point.
Yeah, so it's equal to this plus this divided by half, right? Is 250, 125, 375, right? So, if you know the world going to look like that, would you propose to your boss to run a 3-level experiment? You're wasting money. Okay? So actually, later on, I'll have a lot of so-called mixed level. But when we do mixed level, we can use SAS as well. There are A effect, B effect, C effect, D effect, or the effect, right? Every one of them can be 3-level, can be 2-level. You only pick the one you need to investigate somewhere in between as 3-level. You follow me? Okay? Yeah. And so this is important thinking you have to have before you get into the mess. Otherwise, it's really the computation is really simple. Well, not simple enough. So let me show you how this is done. Okay, I'm still using a regression approach, but I will show you how to do it. Okay, so look at here. What do I have? First, low level, medium level, and high level. Now you see why we use -1 and +1, because in the middle, I have 0, 0, right? So, huh?
You're cut off on the left side.
Oh, again, sorry. So, okay. So, low level, medium level, high level, no problem, right? And then I'll have a low, medium, and high. So if you ignore Okay, don't look at the quadratic part first. Just look at the -1, positive, negative. Here, if we don't have this part, okay, we don't have this part. Just look at the A linear and B linear part. It's just like the 2 by 2 four corner, right? -1, -1, +1, +1, -1, +1, +1, -1. Everybody agree? If you only look at this four corner, this is our O experiment, right? But when we add the middle point, okay? When we add a middle point, A will be 3 level, B will be 3 level, so totally how many observations, how many conditions we have? 3 times 3, 9, right? But when you have 3 times 3, 9, there will be a problem is that when you do the contrast, I know that I can use the contrast here and do the sum product. I can do the sum product here for the A effect and B effect. But that A effect and B effect is based on what? 0 times this, or -1 times this. Okay, so in other words, here, when we do the contrast, okay, 0 times whatever the observation equal to what? 0, right? So in other words, if you use the sum product of linear times linear, you will end up with what? The contrast and the sum of square, just like the old days in the 2 by 2 situations. Because you can ignore all the 0 part, agree? So, people, can you see that if I'm only having this one, and if I'm only looking at a B column and D column, I'm not doing anything different from the 2 by 2 experiment. Can you see that? Okay? And of course, this is the reason why I need you to understand what you've been doing. Because 3 level is different from the 2 level because of that. So now, and then, by the way, the sum of this, if I do the sum of this contrast, should equal to what? 0, right? So I have a contrast 0 here, and then I have a contrast 0 here. Okay? But now here comes the tricky part. You already said it. Hey, just linear. But the reason I have the middle points because I need a nonlinear part. Because in the middle, either a little higher or a little lower, right? I cannot use the average. So in order to do that, I need to make the middle part obvious. So the way how we do it is, there are 2 different ways you can do it. But this is the convention we use, is you make here 1, 1, 1, here 2, 2, 2, -2, -2, -2. Because if you do it this way, 3 positive 1 plus 3 positive 1 minus 3 negative 2, what will be the contrast sum? Well, here, this contrast is 0. What about this contrast?
Should also be 0.
It's still 0. So in other words, they are 0 over 0. That's good. Now here comes the second piece. If I can do this, remember when we say they need to be orthogonal contrast, means what? Not only the sum of itself should equal to 0, the dot products of any 2 of them should equal to 0, agree? And look at this. If I do a sum product of this guy versus any guy, which one you want to pick? Let's just say we'll pick this one. Oh. Okay? Will be 0. So in other words, is that every comparison will be an orthogonal contrast comparison. So first, you can investigate the quadratic effect. And then, here comes the very, very tricky part. Now I have the linear effect for A. I have a linear effect for B. I have a quadratic effect for A. I have a quadratic effect for B. And they are orthogonal. Guess what will happen next? I can have linear, linear. I can have linear, quadratic. I can have quadratic, linear, quadratic, quadratics. Okay? So, first, computationally, would you guys agree? If I have 3 levels, I will end up with 8 degrees of freedom. Two main effect, and A effect here. Everybody see that? If we have 3 levels, we use up 8 degrees of freedom rather than 4 degrees of freedom like before. The second thing is that, can anybody explain to me? I already explained what's quadratic effect for A, quadratic effect for B. Can anybody explain to me what's a linear, linear, quadratic, quadratics, linear, quadratic, quadratic, linear effects really means? Can you see that? So we have 4 quadratic effects. 4 nonlinear effect here. We have 2 nonlinear effect, main effect, and then we have 4 nonlinear interaction terms. What does those things mean? First, okay, linear is easy because we have linear interactions before, right, for the two-way factorial design. So this is like the old days. Okay, now let's talk about linear quadratic for A and quadratic linear for B. Okay, before when we talk about the two-way linear here, is what we're saying is that what? Here's one corner, the left wall against right wall, the front wall against the back wall. And then if there is a significant effect here, means what? Could be from the 0, 0, here. Let me, this require some, I have time. You know what? It's wasting my time. Okay, I just do this. A low, A high, and A in the middle. B low, B in the middle, and B high. Okay? Here are the Knigh effect. In the old days, we said that if this corner, remember we said that if this corner is low, well, actually let's just do it this way. If it's parallel, means there's no interactions. Means what? Here is high, here is low. Okay? If B is low on this corner, B is high on the other corner, or just like this, we can say that there's a B effect, right? And then of course I can do it this way and say that B is high and B is low, and nothing in the middle. Okay? You guys agree with me? This is like the old parallel comparison, right? Low is low, high is high. But then we say when there are interaction means what? When A is low, B is low, everything is low. Like this. But okay, if, okay, we have a situation like this, in the old days means there's crossing, right? It's not parallel. A low, A both low, or A both high, okay? A low and B low, or A high and B high, they're one level. But A high and B high, they're in another level. So there are interactions, linear interactions. So now let's talk about what is the quadratic effect. Okay? I'm going to do it here, but I would like to do it here. If the effect is like this, this is what? There are quadratic B effect, right? B is low is one level, B is high is one level, but somewhere in the middle is another level. So everybody sees this is a quadratic B effect. Okay? So how to come up with a quadratic A effect? It's something like this, right? Let me do it for fun. A is high, A is low is high, but somewhere in the middle is this. That's meant B effect. Agree? So what will be the AB interactions look like is something like this, right? If we can come up with a situation like this, for example, let me make it fun. Yeah. Suppose red means really high. Suppose red means really high. Green means really low. What does this effect look like? Somewhere in the middle, I have a minimum. Agree? Can you see that? How many of you can see that? This one shows that somewhere in the middle, there is a minimum. Because A high, A low, they're all high. Okay, can anybody show me how to do one somewhere in the middle, there's a maximum? How to do that? Just switch the color, right? Everything's gonna be low, 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 low. Except you in the middle. Okay? So this now shows that high, 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 low, 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 the two type of quadratics. There's one more. So this is or, holding water or this. There's one more. What will be the other one? To talk about interactions. This time is really ugly. Is what? Like the hyperbola. Is going this. How many of you know what is a saddle point? You guys know what is a saddle point? And let me show you a saddle point. Because I'm not good in drawing this. And I don't want to just give you the equations without, here. Saddle point. Okay? Here. This is the pure quadratic effect. Holding water or upside down. And saddle point becomes what? Well, the middle is a tricky part. Depends on how you look at it. If you look at it from this way, this point is what? Minimum. But if you look at it from the other side, is maximum. So in other words, is that if I'm going to draw this, is I will have the how am I going to do this? Yeah, I can do this way, and then how am I going to do this? I don't have a good visualization way of doing this, but can you guys see that if I have a saddle point is a two-way interactions? Oh, time to go, right?
You got another 5 minutes.
Okay. Can you guys see that the nonlinear effect, either max or this is a mean, this is a max, and this is a saddle point. You don't have the ability to investigate this kind of stuff unless you have what? The quadratic effect, okay? And that is where we're going, okay? And in order to investigate this, if you just want to say that, hey, Simon, just give me the stupid Excel and then I plug and play. You got it. And it's, 5 minutes, you're done. The thing is that you need to think it through about why we're doing it and what's the benefit behind it. Okay? And what delay our part of our homework too, because I want you to redo exam and make sure you can do it, okay? And for some of the grad student, I think you still can drop this class if you don't really want to go all the way through. I promise you the torture is still there and you have a project coming, okay? And if you want to stay in this class, you got to understand the mechanism. You have to visualize it, okay? For the undergrad student, you don't have a project, but what I require you to do is you can do the Excel from scratch. Because if you cannot do this Excel from scratch, the minute I pass you the SAS, okay, I basically give you a cheating mechanism. And you're gonna, keep going until you get caught if you don't understand what's going on. Okay, and that's what I would like to prevent. Okay, and TA, you give them the exam time due when? Or you haven't given them yet?
Saturday.
Saturday, same time? Okay. Yeah, so you have what? 72 up?
People are asking for extensions, so if you're okay with that, I can extend it.
Okay. Well, but I already cut the homework half. Fine. What due on Sunday? Okay. What due on Sunday? Well, if I keep postpone everything, then you're gonna wait till next spring to finish your homework 10.
Sunday night is good.
Huh?
Sunday night is good.
What?
Sunday night is good.
Sunday is good, right? Okay.